Okay, I want to point out for number 14, it's not an easy question to read, it's not an easy question to understand. However, I'll do the best job I can at the whiteboard. All right? So it says a man ascends the last half of a mountain at a rate 1/2 mile an hour less than the rate during the first half and reaches the top in 3 3/5 hours. On the descent, that's on his way down, his rate is 1 mile an hour greater than during the first half of the ascent, and he accomplishes it in 2 2/7 of an hour. Find the distance to the top and the rate during the first half of the ascent. All right, so I found this to be a difficult question. I think it'd be a good competitive question to give a student, but certainly given time to solve it. So what I want to do is go to the whiteboard. Let's see if we can do that. And the first thing I want to do is just read through it again and find out what they're really looking for. And if you read through that again, you're going to notice in the last sentence, I want to find the distance to the top of the mountain. So what I want to do is kind of draw a visual of this. And I'm going to say, the simplest picture I can come up with, something like this, is the distance to the top of the mountain. I don't know what it is, but I'm going to say this is the distance over here. All right? So x is the distance to the top of the mountain. So distance to top. And again, reading through it, they're talking about miles. So it's going to be in miles. It's going to be in miles. All right? So I got that part. I know they want the distance to the top of the mountain, but they also want the rate. I don't know what that is either. I'm saying it's y. And this is going to be the rate. All right? I got to read that to you. It says the rate during the first half of the ascent. So first half going up. All right? All right, so what I'm going to do is try to figure out something they've given me. And this is what they want, but did they give me anything? And they said on the descent, that means going down, his rate is 1 mile an hour greater. And that makes sense, by the way. So the rate down is 1 mile per hour greater. That's y plus 1 now. So rate down is y plus 1. And it goes on to say that on the descent, his rate is 1 mile an hour greater than the first half of the trip, by the way, up. So that's y plus 1, by the way. And it says it took him 2 2/7 of an hour. 2 2/7. And I don't like mixed numbers, so I'm going to write this as, 16/7 of an hour. And this is a uniform motion problem. I'm going to say it's rate times time is equal to distance. Well, I'm going to write that equation down for you. The distance down is x. His rate is y plus 1. And the amount of time he's given is 16/7. And this is good news for me, and I'll tell you why. I have an equation now, x equals, and that's going to be a 7 on the bottom. And then you're going to get 16 times y plus 1. All right? By the way, I don't know what y and x is. In fact, I know x is a positive number and y is a positive number. All right? Now, certainly, this is not enough to know what x and y. All right? So I want to go back and read. And it talks about, a man ascends the first half of the mountain at a rate of 1/2 mile an hour less than his rate during the first half. And it goes on and says he reaches, so the total time uphill is 3 3/5 of an hour. So it's 3 3/5 of an hour. This is total time up. Total time up. I don't like the mixed number, by the way. Let's see. That's going to be 15, 18. That's the total time up, by the way. And I know on the first half of the trip, right? I don't know what his time is, by the way. So in the first half up. Yeah, it doesn't look right, does it? So first half up. Well, that distance is x over 2, right? What I don't know is I don't know how much time it took. So I'm going to say his time up is t, and his rate is y. Now in the second part, it's x over 2. That's still going up, by the way. Well, now it's going to be, let's see, it's going to be 18 fifths minus t. I don't know what t is, by the way. Now, by the way, as soon as you put another variable in there, I did. It's something I really can't wrap my head around at this point. And then it's going to be times what? And its rate in the second half, what happened? Again, going back to reading it, it's 1/2 mile an hour less than the first part. So it's 1/2 mile per hour less. All right, I got some troubles here, don't I? By the way, this is not my trouble at this point. I like this guy. It's easy for me to understand that. So what I'm going to do is, I'm going to take this first equation, and I'm going to get rid of that t there, right? Not to get rid of t, solve for t. So you get x over 2y is actually equal to t. And this second guy over here, I'm going to maybe write this as x over 2 equals, I'm going to be careful here, right? So I'm going to write this over here as 18 over 5 minus the t, which is x over 2y, right? And then I get y minus 1/2. All right. And I've got, let me sure I did that right, by the way. And I know t is x over 2y, and I got another relationship between x and y. So this is good to know, and this is good to know. All right? So then what do you do? Well, I need to solve this system of equations, by the way. And let me just go through it a little tiny bit, by the way. X over 2. I need to clean this equation up, by the way, because I realize the way it's written, probably not very good. That's 10y. And I'm going to say this is 2y minus 1. And then I put the 10y there. And so what do you get? You get 36 minus, looks like 5x. All right? So let me write this down for you. I get x over 2 is equal to, well, I'm going to put down, let's see, 10 times 2 is 20y. And on top here I get 36 minus 5x and 2y minus 1. I'm going to put a box in this guy over here. All right? Let me get the eraser out and erase the other box I have over there. I'm going to erase this one over here. I don't need that. And I'll just put a little star next to this one over here. And start next one over here. And by the way, I don't find it easy, but this is a system of equations you can solve for x and y. And if you did that, you're going to get an ordered pair. There's going to be a quadratic resulting from this. And the two ordered pairs you get is 8, 5 over 2. And the other ordered pair you get for this thing would be 432. And by the way, I'm not showing you this. You can do that yourself, by the way. I think the worst part about this word problem is reading it and understanding these things over here. Now, someone's going to say, you know, what does this mean? Well, x is the distance to the top of the mountain, so I'm going to say this means 8 miles to the top of the mountain. And what does this mean? This means 2 1/2 miles per hour, which is very reasonable, by the way. Now, this one over here, a little crazier over here, but I'm not going to do the division. But this certainly could be a distance to the top of the mountain, by the way. 432 over 161 miles. That's possible. And this would be this is really slow walking, man. 4/23. I'm not saying it's not possible, by the way. But I want to point out, it doesn't seem likely at this point. I'll tell you why. The reason for that is that if you remember what they said, that his speed over here would be reduced by 1/2 mile. Let me write this down for you. 1/2 mile per hour. So if you have 4 over 23, and you want to reduce that by 1/2 mile per hour, what would you get? You get 46 you would get 8 minus 23, which would be less than 0. It's negative. So this one over here makes no sense. It's no sense. Not possible. So I'm going to conclude over here, the distance to the top of the mountain is 8 miles, and the speed on that first half of the trip, up by the way, is 2.5 miles per hour. So it's, he goes 2.5 miles per hour, and then what happens on the second part he tires, he gets 2 miles per hour. And on the way down, what is he doing? He's doing 3.5 miles per hour. I mean, they're not asking these questions, but that's it. Thank you.